Hi, I'm Shyamala Gauri, Assistant Professor, CSE in Rohini College of Engineering and Technology. Subject code CS3491. Subject name Artificial Intelligence and Machine Learning. Unit 2 Probabilistic Reasoning. In this presentation, I'm going to explain what is Bayesian networks. Network representation of knowledge is used to exhibit the interdependencies which exist between related pieces of knowledge. Bayesian network is a probabilistic graphical model that represents a set of random variables and their conditional dependencies via a directed acyclic graph. For example, a Bayesian network could represent the probabilistic relationships between diseases and symptoms. Given symptoms, the networks can be used to compute the probabilities of the presence of various diseases. Inference process problem domain is with a network of nodes which represent propositional variables xi connected by arcs represents causal influences or dependencies among the nodes. The strength of the influences are quantified by conditional probabilities of each variable. Here shows the example to represent causal relationships between the proportional variables x1, x2 and up to xx as shown in the below figure. Joint probability p of x1, x2, up to xx is the product of conditional probabilities. P of x1, x2 up to x6 is equal to P of x6 divided by x5 into P of x5 divided by x2, x3 into P of x4 divided by x1, x2 into P of x3 divided by x1 into P of x2 divided by x1 into P of x1. In general, for each variable xi, we can write the equation as p of xi divided by xi minus 1, up to x1 is equal to p of xi divided by parents into xi. Here given an example. Harry installed a new burglar alarm at his home to detect burglary. The alarm reliably responds at detecting a burglary but also responds for minor earthquakes. Harry has two neighbors, David and Sophia, who have taken a responsibility to inform Harry at work when they hear the alarm. David always calls Harry when he hears the alarm, but sometimes he got confused with the phone ringing and calls at that time too. On the other hand, Sophia likes to listen to high music, so sometimes she misses to hear the alarm. Here we would like to compute the probability of burglary alarm. Problem statement is calculate the probability that alarm has sounded but there is neither a burglary nor an earthquake occurred and David and Sophia both call the Harry. Here the network is given by the network shows the Bayesian network for the above statement problem statement. Here the probabilities are calculated and shown here. The network structure is showing that burglary and earthquake is the parent node of the alarm and directly affecting the probability of alarms going off. But David and Sophia's calls depend on alarm probability. The network is representing that our assumptions do not directly perceive the burglary and also do not notice the minor earthquake and they also not confer before calling. The conditional distributions for each node are given as conditional probability table or CPT. Each row in the CPT must be summed to 1 because all the entries in the table represent an exhaustive set of cases for the variable. In CPT, a Boolean variable with k Boolean parents contains 2k probabilities. Hence, if there are two parents, then CPT will contain 4 probability values. Here shows the list of events occurring in this network and the probability of the events are shown here. Here, the conditional probability of alarm A depends on burglar and earthquake is shown in this table. In this table shows conditional probability for David calls. That he will call depends on the probability of alarm. And this table shows Sophia calls. Her call is depending on its parent node alarm. From the formula of joint distribution, we can write the problem statement in the form of probability distribution. It is shown in this slide and the output is shown on the slide. Thank you.